Assalamu alaikum viewers. Uh, we are back with another video, and today we are going to explain our simulation of arithmetic operators, logic operators, relational operators, and other operators using our Quartus software. We'll write codes and simulate in our Quartus software, but um, but today we have some difficulties with our software laptop, so we'll explain it here using snapshot. So first, moving on to our objectives, as we usually explain, which are objectives in this lab. We'll learn implementation of Boolean arithmetics logic, like we are using Quartus software to implement our Boolean as arithmetic. How we are going to explain, and we'll learn how to this explain, and we'll write and see is output waveform, and write its code, so that we'll familiar with its operators and operations. This procedure is written here, so it is not necessary to explain this. So first, we have operations like arithmetic operation, which are known to you, like multiplication, division, addition, subtraction, and modulus. Multiplication, multiply. This first symbol is used for multiplication. Second symbol is used for division, and so far addition, subtraction, and last is our modulus, which uses a remainder. So first, module of we write module so that we can initiate these variables like a b c d e f g, and input, will assign input values to a b and output values to c d e f g. uh, with that we perform, for arithmetic operation we need two inputs, and like our output, which we have 1 2 3 5 operators, so we'll need five output values, and for performance, we'll use two inputs, which will perform arithmetic operations. First, we'll assign C equal to A multiply B, which perform multiplications, and it evaluates and give value to C. And second, we have D, which evaluates division, like D is equal to A divide B. We'll assign A and B values 3 and 0, 3 0 to A B, and we'll assign D as multiplication, C as multiplication, and D as division. And E performs addition, F performs subtraction, and G perform modulus. So that Fe is equal to A plus B, and F is equal to A minus B, and G is equal to A plus B, A plus 1, semicolon B1, and modulus with B. And then we have complete our code, so that we just look at our schematic diagram, which shows when a 3 and b is 3. So our first it is going to multiplication, and this addition, these are modulus. I don't have any marker or any annotation, so we'll understand with this. And you can see these are operators, and after that we have output options. Let's see its output waveform. So A was 12 and B was 3. See, and C was A multiplied by B. So we assign A is equal to 12 and B is equal to 3. So 12 into 3 is equal to 36, and d was our division. So 12 divided by 3 is equal to 4, as well as E is was addition. So 12 plus 3 is equal to 15, and F is equal was subtraction. So 12 minus 3 is equal to 9, and G was modulus. So modulus uses remainder. So when we divide 12 in by 3, so we'll get remainder as 1. So now we are moving on to logical operators, and these are logical operators and those parallel signs and exclamation mark, which you will use logical operators. Similarly, as we initialize our operators A B C D E F G H in previous exercise, we also explain initialize this. Now we have three inputs. So in logical operators, we compare two operators with third one, like one a greater than b, then a greater than also c, like this logical operations. So we'll assign uh, assign three inputs and five outputs. So uh, let's see how it's going to work. We'll assign d is equal to a and b, which evaluates to 0, and e is equal to a, b, and so far f is equal to f, g, and h. So here is a schematic diagram. You can look at this a b c, and it is connected to OR gate, and also b is also connected to AND gate. So uh, let's see how output waveform is going to work. And here is our output waveform. And this can show you how it's going to work. So let's move on to our exercise number 1. uh, these are exercise. So first is what do you following evaluates to? Z is equal to 67, and also x 0 and a and 1, and so far and so on. And also we have what value of gamma is displayed if following modulus is run. So here's our code. Similarly, when initiate the our code, and input we now input we have 9 input, and we have 5 outputs. So we'll perform similarly. The code is too similar, so we'll move forward to our next output waveform. And you can see when a is 0, after 0, and b is 1, c is 1, then 1. When this is our input initialization. But q, we can see q is exclamation mark of h, and h we have 0. So and then uh, it is 0 0 0 0 0 0 1, and t was our was also initialized as 0. Then w was also initialized to 1, and x 0, and y into 1, and z into 0. Then we have code for part E, and part E was what value of gamma displayed in the following model is 1. We want to explain the gamma value which is displayed, which value is gamma, it's appear. So um, we have modulus of test logical alpha. Will initialize alpha 2, beta, and gamma, and input as beta and output as alpha 2 and gamma. We have to find gamma value. So assign alpha 2 is equal to not beta, and gamma is equal to alpha 2 parallel to beta. And alpha 2 is b1 and alpha 2 is 0, 1 0, then gamma will be 1. You can see our alpha 2 is beta, so 1 alpha is 1, beta will be 0, so gamma is equal to alpha into beta, so it will be 1. Relational operators. Relational operator is greater, less than, and equal to, and greater than and less than equal to. So let's move on to our code and then how it's going to work. We have 8 initializers and 4 inputs and 4 outputs, and we'll perform our logical equations as e is equal to a. When a less than b, e will be assigned, and when a is greater than b, f will be assigned, and g is equal to a when a is greater than equal to c, and h is when d is less than or equal to a. So how it's going to work: when a was 1 and b was 5 and c was 2, so when a d is equal to, d was uh, d was h into x, so it will be x, and then e was a less than b, uh, which is for a is less than, a was 2 and b was 5, so a is less than 5, so it is 1, it is true. And f was, and a is greater than b, then a is 2 and b is 5, so it is false. It will be appear as 0. And g was when a is greater than equal to c, a is c is 2 and a is 2, and it is true, it is equal, but not greater, but it is equal to c, but it is will see as 1 as on, and h was u of x, and you will give us 1 x. Equality operators. um, First is equal, first is equal is comparing, and second is exclamation mark and equal, it will represent as not equal, and this then we'll compare, when comparing and not equal, and not is equal to, when it is written as exclamation marks equal. So we can move forward. Like first portion is also similar for uh, any of the code. Will initialize our values, and then input input initializer and output initializer. And let's move on to code. Then g is equal to a comma a equal b, so a, it is comparing to a and b, whether these values are equal, but also same. And h is c is not equal to d, x is c is not equal to f, and y is d, case equality with to e, and z is equal to, z is inequality and not equal to d. It is case equality, and upper was logical equality and inequalities. So a is 4 and b is 7, and c is b into 0010, so it is 2. So c will be appear as this, and d. Now let's move on to our g. G is comparing a and b, so g, a is not equal to b, so it is not given into any values, it's 0, and this line will show you. And h is c is not equal to d, and also c is not equal to d, so it is not giving any, so output. And x is equal to d, so it is d is equal to e, and also it is equal to, and this given to 1, and also y and z. um, Exercise number 3 is, what are the following evaluates into x y x p o, it's equations. And let's move on to his code. What is going here? We'll see y is 3b101 is not equal to 3b010, and x is equal to 4b001. Just a second. Yes. Okay. So y is equal to 3b101 is not equal to 3b010, and x is equal to 4b0001 is a comparing to 4b1, and p is equal to 4b101x is comparing to 4b101x, and o is 4b101x is case equality. Upward was logical equality, and last over is case equality, which is will perform in this. So x is a is comparing to b, logical equality, and y is c is not equal to d, and o is g is comparing to h, and p is k is comparing to l. And we'll see how this is our output waveform. And we are short with our time, so we'll wind up its. And bitwise operator is in there, and you can see here, and we'll implement this and assign d is equal to not of a, and e is equal to a and c bitwise, and it evaluates b0100, and e is f is a into a or b, which evaluates to 4b1111, and this g is b x or bitwise x or, and evaluates to be 0110, and c h is equal to a x nor c, so it evaluates b0110. um, Here's our when a is 110, b is 0011, 110 is 12, and 10011 is 3. So c is 0101, uh, and also so on, it's till h. So exercise number 4 is how do you display f is equal to naught of 2 into b01, and g is equal to b1010, or uh, x or 4b101 x or 4b10, and h is equal to 4bx or 1b1. So here's our code, you can see, and output is given here. um, we can learn simulation from live. We'll In the next video I'll explain in live simulation, so you will get better idea. Reduction operator is it is like and or x or. This is first right, and second is not of and, second or not of or, and this is x or not of x or, and so far so on. Then we have three inputs and three outputs. D is equal to and of a, and it is evaluated to 1, and E is equal to or of b, and evaluated to also 1, and f is equal to or x or of b, it evaluates to 0. And we can see our output waveform, which is given to when a is equal to 111 and b is equal to 0101 and c is equal to 0011. Then d will be first 1, it evaluates to 1, and e also evaluates to 1, and f r evaluates to 0. Our last exercise is our second last exercise is about um, and or and XOR operators. uh, let's start this exercise. We have AND of b10 and OR of 3 b101 x and XOR of 4 b101101. So input as ABC and output as DEF. First D is bitwise AND of A, and E is OR of B, OR of B, and F is equal to XOR of C. Here's our output waveform. You can see here. Um, Now we have shift operators. Okay, shift operators. Shift operators are will shift the operator values to left side or right side. First will move shift to right side, and second will use to shift to right side. We have one input and two outputs. So b is equal to a, less than to 1. It will shift to left values by 1, and c is we can use our numbers to check how much it's going to shift. It first in b is 1 and c is 2. So when a is 1010, then b will be shifting into 1. So it will shift in left, right, like 1010 is our then b will be 0110, and it shift as left, and c will be shifting into right as 2, and it will be 0010. Our last exercise is about our what does its values for a is x is equal to 4 b1010, b0110 is equal to 4 b1100, shifting to right side into 1, and also y is equal to 4 b0110 and 4 b1100 and shifting into 1 left side. Now let's move to code. Its code is x will be assigned to a. About upper equations will implement this, and this is our output implementation. Last is our concatenation, and its symbol is which use comma. So a concatenation is used to producing 4-bit number, and we will see in our we'll assign this d is equal to a comma b in brackets. So it is also its symbol is a curly bracket, and we use symbols in curly brackets and separated with commas. You can see in our code, and output is here. You can see, and also we have replication will replicate this code as how much you want to replicate the number we are going to use. When a is 1 on, then c is equal to 4 of a, and the symbol is double curly bracket in which you use our input. So exercise number when b a is equal to 1 and c is 1 1 1 1. Exercise number 7 is so we have concatenation and also replication. When we perform concatenation at C, and we'll be performing our replication at BC and also at B. And here's our when A is on and B is 0 1, C is 1 1 1 1, then D, which replication and concatenation is here. So that was today. We have learned our lab 5, which was arithmetic and logic operators, and replication concatenation we use. Um, so that was about today. I hope you liked the video, and Allah Hafiz.